So today we'll be talking about how we use sample data to make assumptions or suggestions about a population. So before we actually get into it, we have to review two definitions that we talked about earlier in the course. Remember that a parameter is very similar to a statistic, but it's that for a population. So meaning that it's an actual calculated mean, median, mode, range, any of those things, but for the actual population. Now, in reality, it's really hard to get the entire population's data. We talked about this a little bit before, and that's why they actually use sampling to gather a sample of people or things or items and calculate the sample's mean or median or mode, whichever it could be that they want and have interest in. And then they use that mean or that average to make predictions or assumptions or suggestions about what the entire population is doing. So remember, if it comes from a sample, the value is a statistic. If it comes from a population, that value is a parameter. The process of taking information from a sample to make conclusions about an entire population is called statistical inference. This actually happens a lot in research. The numbers and the percentages that you guys hear about online or on the internet, wherever it is, news articles, on TV, when people draw statistics, those are statistics because they come from a sample, and they're actually making very broad statements about a population based off those statistics. It's not malpractice to do so. It's bad practice if they actually didn't carry through their research in a very good way. So we talked a little bit before about there are different ways to just select people to be in the sample. Well, if they don't select people in a random format, then that's actually bad practice. But you'll never hear about that in the headlines. You'll just hear the headline about the statistic that they found. And there are other ways that researchers can do, I can basically say, bad research. We're going to talk about that a little bit in this video and in the next video, where there's other things besides just taking a convenient sample and a voluntary sample that would produce bad statistics or bad results. When we talk about statistical inference and using sample information to make predictions about an entire population, we have to understand what sampling variability is. So sampling variability is basically understanding the fact that if I have an entire population, which can consist of many people or many things, and I just take a sample of that, and let's say I calculate a mean from that sample, an average. Well, that average could be different if I took a different subset or a different group of people from that same population. For instance, let's say I was interested in the students at McEachern and the amount of hours of sleep they get per night. And while there may be 2,400 students at McEachern, let's say I was able to get a sample size of 100. Pretty good sample size. And let's say I found their average sleep time to be 7 hours of sleep. Well, if I went and I gathered a different 100 students at McEachern and asked them, their average may be different from 7 hours. So it's just the idea and the knowledge, knowing that sample data will vary. Not every sample in a population will produce the exact same average. So there is going to be a little bit of wiggle room of what we think the actual population data will actually produce. Well, let's really quickly visit what we've talked about already, which is we need to make sure research is using random sampling to select their people in their sample. And what that random sampling does is it reduces bias because we're not just going through and selecting people that we think will be in favor of whatever we're trying to put in a headline. Random sampling should get a pretty good representation of the population because it's random. We should have a very good proportional amount of people in each type of subgroup that's within the population. Secondly, researchers should use a very large sample, as large as they can get, that's feasible for them. And what this does is it reduces variability. So all that wiggle room that we may have in the variation between one sample and the next, using a larger sample will produce lower variability because if you really think about it, the larger your sample gets, the closer it actually gets to the population size. So therefore, it'll be closer to the population's mean, whatever that may be, than it would if it was a small sample. Small sample, you may find a group of people who only sleep for 5-6 hours a night. But then if you get a larger group, then maybe you'll find that they're sleeping 7.5 hours a night. Well, we know based off of the laws of probability that is actually going to be closer to the true population mean than would a small sample be. This is somewhat of a visual representation of that. If you notice, a smaller sample size creates a larger spread. And remember, the mean is going to be somewhere in the middle. So we don't want the data to be so spread out from the actual mean. We want it to be really close to the mean. So in the second picture, you notice the spread's way smaller, and that's because the sample size is so much bigger. So the larger the sample size, the smaller the spread, which is what we want, because that means we're closer on target to the actual true mean. When we talk about having that little variation from the mean, hopefully little, like this one, instead of big, that amount that we can actually be off from the true population average is called the margin of error. So that is the amount that we're actually thinking that our sample data will differ from the actual population's mean. Now, really good reports or statistics and research, they'll tell you what their margin of error is, how much they think they're off from the actual population mean. Now we're going to look at two websites where the first one, they post a lot of smaller research studies, and it could be basically anything about anything going on in the news today. And the second one is more so about presidential elections. So we'll just look at both of those websites really quick. You can't actually click it since it's in a video, but you can kind of see the link there if you wanted to actually go visit and look at it yourself. But if you click on the first one, you'll come across several different small studies. I just selected one, and these come out daily. So this one, it pertains to us because it came out today. And it's about the coronavirus. So the study, if you look at the top, it says Americans question whether public health systems, our system, can handle coronavirus. So you can go ahead and pause and read it to yourself if you like. Otherwise, I'm just going to read it and you can just keep playing it and follow along. So it says, Americans are only slightly more concerned about their personal safety as the coronavirus pandemic grows, but they're noticeably less confident that the U.S. healthcare system can deal with this problem, or the problem. A new Rasmussen report's National Telephone and Online Survey finds that 65% of American adults are now personally concerned about the coronavirus threat, with 33% who are very concerned. 31% still don't share that concern, but that includes just 9% who are not all concerned. And then it also tells us to see the survey wording, question wording, click here. We're actually going to view that wording on our next video. And it goes on to tell us, obviously, if we want a free update, we're just going to skip all that middle part right there. And it goes on and says, the survey of 1,000 American adults was conducted March 11th through 12th, 2020 by Rasmussen Reports. The margin of sampling error is plus or minus 3 percentage points with a 95% level of confidence. Fieldwork for the Rasmussen Report surveys is conducted by Pulse Opinion Research LLC, see methodology. So let me mention a few things that they did. They went ahead and told us what, obviously, their report was about. They told us the percentages of their findings. So they basically told us that 65% of Americans are now personally concerned, with 33% very concerned. And obviously it gives a few more things there. But down here, it tells us that they surveyed 1,000 American adults. Well, that's a large sample. But if you compare it to the population size, it's not even a small 1% of the population. So technically, how close or how good of a sample size is it? It's questionable. But if you look at it, it's very recent data, and they tell us the margin of sampling error. So that's our margin of error is plus or minus 3. So now let me go ahead and explain a little bit better what margin of error means now that we have an example. So what they are telling us is that in their sample, they found that 65% of adults are personally concerned about the coronavirus threat, but it has a margin of error of plus or minus 3. So that's letting us know, although in their sample they found 65% to be concerned, that number could be off by plus or minus 3 percentage points. So what does that mean? That means the range of people in the entire population they're predicting is concerned about the coronavirus threat is plus or minus 3 percentage points from 65. So if I go down 3, that'll put me at 62. And if I go up 3, that'll put me at 68. So basically what they're saying is, yeah, their statistic was 65% from their sample of 1,000 people. But they're predicting that they could be off by plus or minus 3 for the entire population. So what they're telling us is that they're 95% confident that the actual percentage of people who are concerned in America are within 62 to 68%. So that's what a margin of error tells us. It tells us basically what they think the entire population's number will be between based off of their sample data. So we can look at it for the percent of people who are very concerned. So notice here's our very concerned. It tells us that 33% are very concerned. Well, their data has the same margin of error no matter what because they did this research all together. So basically, the percent that we can expect are very concerned across the entire nation, not just in their sample, will be plus or minus 3 percentage points from their sample statistic. So if we go up and down 3, that's 30% and 36%, basically if I'm adding and subtracting 3. So really, they're saying that they're predicting the population percentage of people who are very concerned about the coronavirus are between 30% and 36%. So that's how you interpret a margin of error. Like I said, good research, they'll tell you their margin of error. But most people don't look for it. They just read a headline and they just take it for what it is. So not only should you look for small things like that, and that kind of tells you about the researcher's variability, you should also look at the methodology to see how they actually gathered their data. The methodology should tell you what type of sampling they used. Did they use a convenience sample? Did they use a random sample? So I just snipped the methodology there for this exact same study. I'm not going to read you the entire methodology. You can read it if you like, but basically just to summarize what they did here is it does tell us that they did automated calls and they randomly selected the people who they called. So if you look right here, calls are placed to randomly selected phone numbers through a process that ensures appropriate geographic representation. So they're letting us know they used random sampling, which is they're calling it randomly selected, and they made sure they had the appropriate geographic representation. So they're making sure that their sample data looks like their population data. And it tells us, obviously the time they called, etc. They make sure they show us that they got people in the evening so that, maybe they're not at work, but they also show us that they got people on Saturdays in case you have people who work in the evenings on the weekdays, and then they also showed where they got people on Sundays. So they're kind of showing us that we didn't just rely on people who work 9-to-5 jobs. Some other things that are important, if you read it, it tells you that they use the exact same automated voice to call every single person so that basically the question sounds exactly the same, so nothing sounds leading, and etc. We'll get into more of those type of things that are important on the next video as far as making sure the questions are written appropriately, make sure, there's no variation in how they're told to people, etc. But overall, every good research study will have a methodology that people can actually read and make sure they actually did some legit research when they put out a headline. Because there's so many researchers who will just, go ask some people and then just put out a headline, and you don't know if they just ask people who would be in favor of that anyway, or you don't even know how they asked the question, if they asked the question in a leading way. So from the second link on this page, so this link here, what that page does is it basically tracks the trends in the polls, and it doesn't do it itself. It actually gathers all the different polls that were done from different companies, different news stations, as you can see, during presidential elections. So the last one was obviously Hillary Clinton versus Donald Trump. And although we already know how it turned out, we can kind of look back at the data to see what the trends were, and as far as looking at the margin of error, how that changes with the different sample sizes that the different companies had in their study. So looking at the first one, The Economist, if you look at it, they had Hillary Clinton at 49%. So basically 49% of their sample reported that they were in favor of Hillary. 45% of their sample reported they were in favor of Donald Trump. Notice the sample size is pretty big. I mean, it's 3,669 people they actually surveyed, and these are their percentages they got from those. Now, they did not report a margin of error, so we don't really know how much they expect these numbers could be off from the actual entire nation. So let's go ahead and look at Bloomberg's study. They reported Hillary Clinton at similar numbers, 46, Donald Trump at 43, but they do have a margin of error plus and minus 3.5 points or percentage. Now notice their sample size is pretty small, and if we look at Fox News, their numbers are similar. I mean, they're both all in the 40s, a little bit more in favor of Hillary, but notice they have their margin of error is a little bit smaller. It's plus or minus 2.5 percentage points. Well, look at their sample size. Their sample size actually went up, and that made their variability go down. So basically, they're more confident in their numbers because they're thinking it's closer to the actual true population's data. And the last one, let's look at NBC's news. They have Hillary Clinton at 51%, Donald Trump at 44%. Notice their margin of error is very small, plus or minus 1 percentage point. So they're thinking that their sample data of 51 and 44% is only going to be about 1 percentage point off from the entire population's feeling about the presidential election, which way they're going to go. So basically, if Hillary Clinton was plus or minus 1 percentage point, they're saying the entire population is going to be about 50% in favor to 52% in favor for Hillary Clinton. And then plus or minus 1 for Donald Trump would be 43% to 46% would be in favor of Donald Trump. No matter which way it goes, it would look like Hillary Clinton was supposed to win at that time from their poll. Notice their sample size, though. Their sample size is huge. That is what made their variability so small, because the closer they get to the population size, now that's obviously very far from it, but the larger their sample size is, the closer they get to their population, which makes their actual numbers closer to what they believe the population's mean would be, or average would be. So that's why their variability is going down, because their sample size is so big. I wanted to look at, before we leave this page, just one other thing about margin of error. So we'll use, let's use Bloomberg's as an example. So the study for Bloomberg, if we look at that for a second, we'll see that they had Hillary Clinton in favor by 46%. But if you consider their margin of error, where they're really thinking that the entire population percent of people in favor of Hillary Clinton could be down 3.5% from that number or up 3.5%. So if we take 4.5 from 46, that puts us at 42.5%. And if we add it, so we're doing it to 46%, I'm adding and subtracting 3.5. All right, so it could be anywhere from 42.5 to 49.5%. So they're thinking Hillary Clinton's true percentage, or people in favor of her, could be anywhere from 42.5 to 49.5. Now, if we do the same thing for Donald Trump, 43%, and we add and subtract 3.5, that's 39.5 to 46.5. Well, I want you to notice what could happen here. If they were actually off for Hillary Clinton's number, if their statistic was off by it being off in the low end by plus or negative 3.5 points. So basically, if the data was down 3.5 percentage points than what their sample data showed, but then Donald Trump's was actually higher than their sample showed, if the population's feelings were higher than what the sample data showed, that would actually put Donald Trump in the winning. So their data being so close to another and their margin of error being kind of larger percentage point, you're not going to have some humongous margin of error. It's going to be kind of, in the low end. But it's still high compared to these other ones. It could go either way if you look at the margin of error. It could go in favor of Donald Trump if they're off by 3.5%. So hopefully kind of see how that margin of error works. Let's go ahead and look at a visual representation of how bias and variability can affect research. So if we think about wanting to be unbiased, basically researchers actually using random sampling and their questions aren't leading and they got everything going on for them, well, that means their research would be on target. Notice in the first diagram, that data is not on target. It's far from the target, therefore it has high bias. It's not on target. So every time you think about whether or not it's on target, that's whether or not it's biased or unbiased. So unfortunately, in the first diagram, it shows bias because it's not on target. It's away from it. So that's why it says high bias. Now, look at the actual data itself, or the dots in this sense. If they're grouped together, it has low variability. That means that, there's not a lot of spread in the data, so we could expect a low margin of error. So that's actually a good thing. It's good that they're actually grouped together, but it's bad that they're not on target. So that's why it says this diagram is showing high bias and low variability. In the second diagram, I'm going to call this my second diagram, it actually is gathered around the target. So maybe the researcher made sure that they did all the things they need to do to make sure they have very low bias, but their data actually has high variability, which probably they didn't have a large enough sample size, so they have large variability in their data. And therefore, their data is not going to have are not going to be very good at predicting what the population could be around because they could have a large margin of error. In the third diagram, if you notice, it doesn't have a lot going on. This is actually the worst case. One, it's off target, so it has high bias. And second, look how spread out it is, so it has high variability. So this is the worst thing that could happen in research, but there's still going to be a researcher who thinks that they didn't waste their time and they want to go ahead and publish their work somewhere, so they're going to find some low-end journal to publish their work, which just happens all the time, and then someone's going to read their article that's in that low-end journal, and then someone's going to make a headline of it on the internet. And guess what? Nobody goes back and reads what the actual researcher did to gather their data and how to select their people. So that's why you guys need to make sure you actually be cautious of things that you just read in the headlines or hear in the news or hear that someone else read, or etc. Now the last diagram, that is what researchers want. They want it to be directly on target, meaning that they have very low bias or no bias at all. So they want to be on target, meaning they probably did everything they needed to do to make sure they used random sampling, making sure they didn't use leading questions, etc. And they also have low variability because it's nice and grouped together. So with that low variability, their data is not going to be really spread out, and they're going to have a low margin of error, which is really good for their research because that means their sample mean, or whatever it is they calculated in talking about and trying to generalize, is actually going to be a good predictor of what the population is actually doing, because their sample data won't be far off from what they predict the population would actually be doing. All right, so lastly, let's summarize. So we mentioned earlier, to reduce bias, researchers should be using random sampling, and to reduce variability, they should be using a large sample size. All right, till next time, adios.